All right, we are ready to get to the meat of what today is about, and that is what's called hypothesis testing. This is also probably the most commonly used and perhaps the most important piece of statistics. And unfortunately, I only get to give you one day of it in what would in a normal statistics class be several weeks on hypothesis testing. But at least if I can give you just a taste of what it's about, you might have a better understanding should you get to enjoy a statistics class in college. Okay, the whole idea behind hypothesis testing is that we have performed an experiment. That's really critical that you understand that this deals with having performed an experiment. You've gone out and tested something, and you want to see if your results are what we call statistically significant. Did your results, maybe it showed an improvement in something, but your question is, did it really improve, or was it just kind of a fluke of the sample data I did? So when we're talking about statistics, we actually set up a hypothesis. If you think back to the good old scientific method that I'm sure you've been drilled with many times, you have a hypothesis of what you think is happening, and then you try to test it and prove it to be true or false. Okay, well, in statistics, we get very technical about the terminology we use. So it's really important that you get a handle on the terminology here. You'll see you can have what's called the null hypothesis and the alternative hypothesis. What you do when you're proving things statistically, you set up the null hypothesis to be what you don't think is happening. You're trying to prove this one wrong. We're trying to prove that the null hypothesis didn't work. So this is the one we tried to disprove. And then the alternative hypothesis, often sometimes called the research hypothesis, is what we think is actually true. Okay, now, of course, it's math and it's stats. We have to have symbols for everything. So the null hypothesis, null meaning none, consequently, they use a 0. So we write capital H with the subscript of 0. That means the null hypothesis. What we're trying to disprove. And then the alternative hypothesis, we write with capital H, little a for alternative. And that's actually what we think is happening. Okay, the first part of your problems today are just trying to get you to figure out which is the null and which is the alternative. And just giving you some situations. So if you read this first one, a company is testing airbags. And the researchers have been studying these airbags, and they think that they do not open properly. They think that these airbags are malfunctioning. So my question is, what's your null hypothesis, and what's the alternative hypothesis? Once again, the null is what you're trying to disprove. The alternative is what you think is happening. For many people, it's easier to do the alternative first, because what do you think is happening? Well, we think that the airbags do not open properly. That's what the researchers believe is happening. So what they're trying to prove then would be the opposite. What's the opposite of that they do not open properly? You said it. The opposite then would be the airbags do open properly. So then they would set up a test to show where the airbags are actually opening properly. You'd always, when you do the test, you're testing the null hypothesis. Okay, here's another example, and I know this gets a bit confusing until you get the hang of it. We have developers of a new paint product. They believe that the new paint dries quicker than standard paint. So once again, what's the null and what's the alternative? Well, I think it's easier if you do the alternative first. What do they think is happening? They think it dries quicker, so we should then set our alternative up to be that the new paint dries faster. Consequently, the null hypothesis is the opposite. And how would you state that opposite? The new paint dries at the same rate or slower than standard paint. Because you realize if one is faster, the other one could be equal to the old or slower. So we had to have both situations there. So that's a little taste of how you do null and alternative. We're actually going to get into the statistics of how you prove or disprove this. And as always, it's going to come back to the normal distribution, some z-scores, and using our charts to come up with the percentage probabilities of what's happening. Okay, to actually perform a hypothesis test, these are the steps. On several of your problems, it's going to ask you to do each of these steps, and we are going to, and as I do examples, do each of these steps. So you go through, this is kind of like scientific method. You have to go through each step and list it out. So when it says define the parameters, if you recall, parameters are numerical data that come from a population. The parameters have to come from the entire population. What numerical information is needed here? What do we need to know? Number two, we have to set up our null and alternatives, and we write them in math symbols, which I'll show you here momentarily. Then we have to set the criteria for the test. And when you set the criteria, there's two parts. You have to say what kind of a distribution are you using, and this is where we can do weeks and weeks of this. Right now, you guys only know the normal distribution. There are others. So we could, right now, yours is always going to be the normal because that's the only one we know. And then the second part, you have to set the level of confidence you want for the null hypothesis. Okay, they're going to write it as P for probability, and it's going to say, in this case, less than 0.05 means they want the probability less than 5% that the null hypothesis is true. Consequently, you're saying you want to be 95% confident that your alternative hypothesis, what you think is happening, is true. So 0.05 is the same thing as being 95% confident. If they say they want it less than or equal to 0.01, then that's the same thing as being 99% confident. But it's how our results will turn out when we do our actual normal curve study. Finally, then, you get down to the number crunching. Step 4, you have to list the sample evidence. The sample evidence is all the statistics you need to know to do this. And I've listed here all that you will need to know. You'll need to know the number of items that were sampled, the mean of the sample, the standard deviation of the population or the sample. The sample, of course, has to be more than 30 for this sample standard deviation to be valid. We'll have to calculate good old standard error that we were doing last class, and then you get a new statistic. It's called Z star, better known as the test statistic. Now, I've told you in the past that Z cannot be, we can't use the old raw minus mean over standard deviation formula because that applies to populations. Well, they created what's called the test statistic, Z star, to serve a similar purpose, but what it's doing, it's not comparing the raw score to the mean, it actually compares the sample mean to the population mean. So when you want to calculate Z star, you'll have to have the sample mean minus the population mean. In other words, what's the difference in those two means? And then you're going, rather than dividing by standard deviation, it divides by standard error. That's going to be the critical formula in doing these problems. Okay. Last but not least, then, once you've calculated that Z star, you're going to use, it'll basically give you a Z-score. You're going to go look it up in your table and find out what the percentage of the curve is that we're using here. And depending on what percent we get, we'll then, at step 6, we'll decide whether our hypothesis, the null hypothesis, was true or false. Now, this is where statisticians are a little funky. If it turns out that the null hypothesis was indeed wrong and our alternative, what we thought was happening, was true, we'll get that to be true, and we'll excuse me, I just had a major interruption, and I'm not sure where I last left off, so I'm going to say that last piece again, since it is a bit confusing. If our probability comes out to be small, very small, less than the number we set, which is what we want, that means that we have proved that the null hypothesis was wrong, and we call that rejecting the null hypothesis, or some people call it rejecting the hoe. If the probability comes out to be a larger number than what we set as the level of confidence we wanted, then that means we have not disproved the null hypothesis. But instead of saying we accept the null, though, they have to use a double negative and call it you fail to reject the null hypothesis. I know that's confusing. We'll work on it as we go through this. I'm going to stop this right now and then set up to start the two problems.